Okay, last rule is the quotient rule, and you know that quotient, well, you've seen this before, it's one thing on top of another. So in this instance, we're going to call this bit on the top, we're going to call it u, and this bottom function, we're going to call that v. So y is u over v, and the quotient rule tells us that dy by dx is, well, it's du by dx times v minus u times dv by dx. So that's the top bit, and that's kind of similar to what we had with the quotient, with the product rule, where we've got one thing differentiated times the other not differentiated, and then we've got a minus, so then we've got the same, one thing not differentiated, one thing differentiated, and that is over v squared. Right, let's have a go at using it for this example here. So we're just going to substitute exactly what we've got here into that formula. So our u is x, so du by dx is just going to be 1. And our v is x squared plus 1. Now we want to subtract, and now we don't differentiate our u, so it's just x, and then we do differentiate our v, so we get 2x. And then that is over x squared plus 1 all squared. So if we try and neaten this up, then we've got x squared plus 1 minus 2x squared over x squared plus 1 all squared, which is 1 minus x squared over x squared plus 1 squared. Here's another way of writing the rule. So if we differentiate this quotient, u over v, and that's what d by dx means. That means differentiate this. So differentiate this quotient, and then that's the rule. Okay, so now if we've got y equals 2x plus 1 over x plus 2 squared. So our u is this, and our v is this. So let's write it out properly this time. So we want to say that dy by dx equals du by dx v minus u dv by dx over v squared. So then if we substitute in, move this all up, when we substitute in, we get, if we differentiate our u, which is this bit, then we get 2, and then we multiply that by v, which is x plus 2 squared, take away, now we don't differentiate it, so we've got 2x plus 1, and we do differentiate the v, so this is chain rule, so if we, the mum is the squared, so the mum is the squared function, so if we differentiated x squared, then we get 2x, so we're going to get 2 times x plus 2. And then we've got to multiply by what we'd get if we differentiated the baby. The baby's x plus 2, so that differentiates to 1. So that's the top, and now the bottom is x plus 2 to the power of 4, because it's x plus 2 squared, all squared. So now we've got 2 of x squared plus 4x plus 4 minus, well, if we multiply out, well, we've got 2 at the front, and then we've got 2x squared plus 5x plus 2, because we do, yeah, okay, all over x plus 2 to the power of 4. So if we keep the 2 out the front, then we've got x squared, take away 2x squared, so that's minus x squared, 4x minus 5x is minus x, 4 plus, minus 2 is plus 2. So and then that's all over x plus 2 squared. So we can take out a minus, so then that will give us 2 times x squared plus x, take 2 all over x plus 2, oh, that was supposed to be to the 4 there, and it is here as well, and then we can factorise that top bit to x plus 2, x take 1 all over x plus 2 to the power of 4, and we can cancel that with one of those, so then that gives us minus 2 times x take 1 over x plus 2 to the power of 3. Okay, pause the video please and have a go at doing this one, and then unpause it in a minute and see if you're right. Okay, so you should have labelled these, the top function as u and the bottom function as v. Then we've got dy by dx equals du by dx, v take u times dv by dx over v squared. So substituting all that in, first we've got to differentiate u. So this is an example of the chain rule. So the mum is this 3 sine function, and the baby is the 3x. So if we differentiate 3 sine something, then we get 3 cos of that thing. So the baby stays the same, 3x. And now what will we get if we differentiated the baby? Well, we'd get 3. And our last thing to multiply it by is v, which is x cubed. Now I've got to take away, well, the u stays as it is, so 3 sine 3x. And then we differentiate v, and if we differentiate that, then we get 3x squared. So then that's all over x to the power of 6. So now multiply out, see if anything nice happens. So if we collect together, we've got 3 times 3, so it's 9x cubed cos 3x minus, again we've got 9, and then x squared sine 3x over x to the power of 6. Move that all up. Then we've got, well, we can take the, well, we can cancel that, and then that will go to a 4, because we're dividing top and bottom by x squared. And we can take 9 out at the front, so we've got 9 times cos, oh, x, 9 times x cos 3x minus sine 3x all over x to the power of 4. So don't miss that little x that I missed out there. It's important, okay?